Good morning. We are attempting here to use some tools and colorize and test smoothdraw 3.2.6 to do some math, which is in quotes because math for me is always something that's not quite what everyone else thinks it is. Math is SketchUp, and math is AutoCAD, and math is shapes. Math can also be what everyone thinks is math. So we're going to look at now multiplying polynomials. Multiplying polynomials with a grid. Now, as we do this with the grid, we're going to try to do a shape, which we don't even know what it looks like, but we'll feed this with another video. We're going to do the shape that's 3x squared plus 5x, just x. Let's see if we can lose the erase here. Here's the erase. That didn't work. And that don't work. So let's see what the erase is. Drawing media. Let's see if we can just pick another color. And that didn't work. So we're just going to do that and try again. 5x squared plus 3x plus 7 is one function, and the other function was going to be 2x squared minus 5x plus 15. Don't even know if or what they look like. They might not even necessarily be solvable, but they are definitely graphable. The roots might not be real, and we're going to call this f of x and call this g of x. And we're going to try multiplication using a grid. And mostly what we're trying to do here is show and colorize how this lines up with the lattice method, which all kids love and all parents hate, which is based on Napier's bones. We're also going to talk about what is standard. Is it to go from lower power? Do we go x to the 0, x to the first, x to the second, x to the third power, or do we do x to the third, x to the squared, x to the 1, and x to the 0? Remember, anything to the 0 power is 1. And we'll be looking at Mathematica and Professor Wildberger to do so, but we're going to now lay out a grid that's going to have spots for 1, 2, 3, a 3 by 3 grid, because we have powers to the second power. So we're going to try to do this with a straight edge here, which is not so easy, but we're working on a board that's called a bamboo board. So you see me just kind of screwing around. There's 1, that's 2, that's 3. So we've got 1, 2, 3 columns, and we're trying this again here. We've got 1, 2, and finally 3 rows. We've got a little spot on the side here, and now I'm going to kind of freehand this in. And we have some spots to put some things down here as we start thinking about diagonals coming down. And now we're going to remember that the first one in the top is going to be the squared power, x to the first power, and x to the 0. And along here, along this side, we're going to go the same thing, x to the second power, x to the first power, and x to the 0, remembering x to the 0 power is 1. So we then write out our equation, 5x squared times 3x plus 7, and we have 2x squared minus 5 and plus 15. I will point out that for many of you it's probably a better idea when we start thinking about coefficients to make that plus a minus, because then you won't lose the coefficients. With that in mind, we are going to realize that x squared times x squared is going to be x to the 4th power. So for now I'm going to change a little bit of color here. And we are going to make this times this is an x to the 4th power. X squared times x to the 1st is a 3rd power, and so this is a 3rd power and this is a 3rd power. X squared times x to the 0 is a 2nd power. X1 times x to the 1st power times x to the 1st power is a 2nd power. And x to the 0 power times x to the 2nd power is a 2nd power. We can now look at again and realizing a kind of a pattern is setting up here. We're going to now realize that x to the 1st power times x to the 0 power is x to the 1st power. X to the 0 power times x to the 1st power is x to the 1st power. And then these are just to the 0 power. You'll see this is going to look very similar to the mathematics of place that comes out of determining determinants of matrices and out of the lattice method. However, we don't have to run with our little kind of funky diagonals. We just have to realize that we're going to fill in off of this chart. So we're not going to be we're going to be doing additions, and I guess when we do additions, we're going to have to figure out how we're going to do that here. So we're going to map our additions down kind of diagonal. This is going to come down here. These here are going to go down there. These here will go down there. These, I guess, will go here, and this will go down to here. It being the 0 power, 1st, 2nd, 3rd, 0, 1, 2, 3, and 4 powers, or the exponents of x to the 4th, x to the 3rd, x squared, x to the 1st, and x to the 0 power. So that said, we can now realize we can go 2 times 5 is 10. 2 times 3 is 6. 2 times 7 is 14. Minus 5 times 5 is minus 25. Minus 5 times 3 is minus 15. Minus 5 times 7 is minus 35. 15 times 5 is 75. 15 times 3 is 45. And 15 times 7 is 105. And we can go ahead and add up each of our kind of patterns here. And I'm not going to be able to do the color thing too much, but I'm going to add up this pattern going down. So that's 105. We can add up 45 and minus 35. I'll try a different color. And minus 35 and 45 is a positive 10. See if we can get the red thing going here. 14 minus 15 is minus 1. Plus, so this is 74. We now can look, that was to the 2nd power. We can now look to the 3rd power, and we have a minus 19. See if I can get another power here. Minus 19. And we have 10 here. So we have, in effect, multiplying out these polynomials in this format is pretty better than it would otherwise be. Of course, we want to realize what we're going to look at later is this is just a shape divided by a shape. That's what it is. You're transforming one shape with another shape. So what do we end up with? We end up with 10 times x to the 4th minus 19 x cubed plus 74 x squared plus 10x. Checking the math here, checking the signs mostly, and then plus 105. So this function turns out to be the multiplication of this function times that function. And we'll do it again with division, but you see this format here kind of aligns with what we're going to call the diagonal math that comes out of the grand conspiracy of making our kids think, that comes from everyday math and methods like that. Thanks for listening. That was, for those who want to know, this was smoothdraw. Was the engine that did the writing. Bad script by me. It was a bamboo tablet which I will suggest to anyone who's going to get going doing math on a computer. You need to have some sort of capture device. A bamboo tablet's as good as any other. There are other ones for the Apple as well. Mouse just doesn't cut it when you're trying to think mathematically. And we were using Camtasia as a capture tool. Thanks for listening.